All right, so you're an architect on Azure. You live and breathe uptime, right? But what happens when the cloud itself, well, fails? That's what we're digging into today. We're going to build a mental model for real-world resilience, looking at the patterns that make the difference between a system that crumbles and one that's basically unbreakable. Let's jump right in. So here's the plan. We're going to go from the micro all the way to the macro. We'll kick things off with what happens when a single server rack goes down. Then we'll zoom out to surviving a total regional outage, managing global traffic, and even how to handle failures inside your own application. And stick around because at the end, I've got a super practical checklist you can literally take and use on your next project. Okay, let's get into it. And first things first, we've got to talk about mindset. This is huge. Before you even think about deploying a VM or writing a line of code, you have to get this part right. Because in the cloud, resilience isn't about planning for if something fails. It's about planning for when it fails. And this quote from Amazon's CTO Werner Vogels just hits the nail on the head. Everything fails all the time. You know, it perfectly sums up the reality of large-scale distributed systems. When you're dealing with thousands of servers, network gear, and all these dependencies, failure isn't just a possibility, it's a statistical guarantee. So our job as architects isn't to try and stop every single failure. That's impossible. It's to build systems that can take a punch and keep on going. All right, mindset is set. Now, let's start small. We're going to begin with the most common kind of failure you'll see, a local outage. Basically, anything that can go wrong inside a single data center building. So let's paint a picture. You've got your critical order processing microservice, right? And it's humming along on a single VM. Then, poof, the physical server it's running on has a power supply failure. What now? Well, without the right architecture in place, your service is just down. Simple as that. This is problem number one we've got to solve. And our first tool to fix this is the availability set. Think of this as your first line of defense, your bread and butter. It's a pretty simple concept. You just group two or more VMs together into a set, and you're essentially telling Azure, hey, whatever you do, don't put these VMs on the same physical rack, and please don't do maintenance on them at the same time. And boom, just like that, you've protected yourself from the most common kinds of hardware failures. Okay, so an availability set is awesome for handling a failure in a single rack. But what if the problem is bigger? What if the whole data center building has an issue, like a major cooling failure or a big power outage? Suddenly your availability set isn't going to save you. We need to level up our thinking. And that's where availability zones come in. Now, the difference here is absolutely critical, so listen up. Sets protect you from failures inside a single building. Zones protect you from failures between multiple separate buildings. See, availability zones are completely independent data centers within a single region. They have their own power, their own cooling, their own networking. So if one entire building goes offline, who cares? Your app just keeps on running in another one. Here's the bottom line. If you're on a tight budget, maybe sets are fine. But if your application is mission critical, zones are absolutely non-negotiable. Okay, so we've covered a rack failure. We've covered a whole data center failure. Now it's time to zoom out even further and talk about the big one, the really scary one. What happens when a whole Azure region gets hit by a major outage? It's rare, yeah? But it's catastrophic when it happens. Well, the answer is pretty simple, really. The only way to survive a regional disaster is to not be in just one region. The solution here is multi-region deployment. And that's exactly what it sounds like. You run a copy of your application in a totally separate Azure region, probably hundreds, if not thousands of miles away. You can do this a couple of ways. Active-active, where both regions are live and serving traffic, or active standby, where the second region is just sitting there, ready to take over in a flash. So, you did it. You've got this amazing multi-region setup. Awesome. But wait, that's only half the story. Think about it. If your main region goes down, how do your users actually get to the healthy one? How does their traffic automatically get rerouted? This is a global traffic problem. And in the Azure world, this decision really boils down to two main services, the older Traffic Manager and the newer Azure Front Door. The big difference between them, it's all about speed and smarts. Traffic Manager works at the DNS level. It's reliable for sure, but DNS can be slow to update, so your failover might take a few minutes. Front Door, on the other hand, is much more modern and intelligent. It works at the application layer and uses this cool tech called Anycast to get your users to the nearest and healthiest endpoint on Microsoft's massive global network. And its failover, it's practically instant. So here's the deal. For any modern web application or API, Azure Front Door is almost always going to be your best bet. Plus, it has a web application firewall built right in, which is a huge win. And this is exactly how it all comes together. It's actually pretty elegant. Your global load balancer, let's say it's front door, is constantly pinging your application in both regions. It's asking, are you healthy? Are you healthy? The second those health probes to your primary regions start failing, bam, it detects the outage and instantly stops sending traffic there. All new requests are immediately rerouted to your healthy secondary region. And the best part? If you do it right, your users have no idea anything even happened. Okay, let's recap. We've built this incredible fortress to protect us from infrastructure failures, from a single rack all the way up to a whole region. But what about failures that come from inside the house? Let's be real for a second. Most outages aren't caused by a hurricane hitting a data center. They're caused by us. A bad deployment, a nasty memory leak, a buggy third-party library. We have to architect for our own mistakes too. And this is where the concept of blast radius becomes so important. It's a simple question. When one of your microservices blows up, how much of the rest of your system does it take down with it? In a really well-designed system, the damage is contained. But in a poorly designed one, a single failing service can trigger a domino effect, a cascading failure that brings the whole application to its knees. Our job is to build fire breaks to stop the fire from spreading. So how do we actually build these fire breaks on Azure? Well, the magic word is isolation. If you're on Kubernetes, for example, you can use separate node pools for your most critical services. If you're using App Service, you should deploy your key microservices into their own separate app service plans. That way, a misbehaving service can't hog all the CPU and memory. And then, in your actual code, you can implement patterns like the circuit breaker. It's basically a smart switch that stops your app from hammering a downstream service that it already knows is broken.
Phew, okay. We have covered a ton of ground here, right? We've gone from a single server rack all the way to global failover and application level failures. So let's pull all of this together into a simple, practical checklist that you can use to gut check your own architectures.
Seriously, take these questions back to your team tomorrow. Number 1, are you actually using availability zones for all your production workloads? Be honest. Number 2, for your most critical Tier 0 services, do you have a real, documented multi-region strategy, or is your strategy just hope? Number 3, is there a global load balancer like Front Door or Traffic Manager in front of your app, and is it configured the right way? Number 4, have you isolated your critical microservices, or are they all crammed onto the same compute, just waiting for one to take down the others? And finally, the really big one, have you sat down and defined the blast radius for each service? Do you actually know what breaks when something goes wrong? And I'm going to leave you with one last and maybe the most important thought. An architecture designed for failure that has never been tested isn't a plan. It's just a hope. It's a theory. The next step, the real work, is to embrace chaos engineering. You have to intentionally break things. I'm serious. Go run disaster recovery drills. Purposefully shut down an entire zone. Kill some pods. Test your global failover. Because at the end of the day, the only way you can be truly confident that your system will survive a failure is to cause one yourself.